Hey, how you doing, Speed Shop TV family? Dan Maslic here again. What we've got here is a 2003 Big Dog chopper with an S&S Super 107 cubic inch engine. Reason this is here is actually twofold. This bike has a charging system problem, and what we're going to do is show you today how to diagnose a charging system on this type of bike. Most bikes have the same type of charging system where you basically got a set of flying magnets on a rotor that they basically excite a stator, and that stator ends up putting out an AC signal to rectifier regulator, which then of course in turn charges the battery. Now this bike, the complaint is that it's not charging, and the other thing is, of course, because it hasn't been charging, the owner hasn't ridden it in a while, and so what we're got to do is get it started. This thing doesn't start. It's a carbureted engine, and being that it's carbureted, chances are it's a simple case of just bad gas. It's been in there for too long, hasn't been run, and of course carb could use a little bit of cleaning. So we'll clean the carb up, we're going to change the fuel out, and once that's done, we'll get the engine running. We're going to double check the ignition too, because it looks like one of the spark plug wires might be a little bit chewed out. So we're going to end up basically running it over, get the motor running. Once the motor's running, engine's running tip top, then that's what we're going to do, is then move on to step 2, which is to charge the system. So stick with us, and like I say, I'll give you a quick rundown of what we're going to do to get this thing running, and then of course how to diagnose the charging system. Alright family, first thing we're going to do to get this thing running is get this fuel out of the tank. God knows how long this fuel's been in here. I don't like to take the chance, even though I hear from a lot of people when we go to work on a car, do something diagnostic for them, of course get a car running that hasn't been running in a long time. Plenty of times I've asked the tech working on it, is there fresh fuel? Is there fresh fuel? The answer is always, yeah, there is, there is. Never take their word for it, family. It's lies, it's all lies. 9 times out of 10, when a car hasn't been running for a while, I don't care if it's carbureted, fuel injected, whatever, if the system is open to the atmosphere, if it's vented, the fuel probably gone south. So it typically doesn't last longer than 30 days before all the front end, the light components in that fuel, the hydrocarbons that are in that fuel, you've got a mix of long chains, short chains, basically heavy and light components. The light components are what evaporates easiest. That's one of the reasons that when you're starting the bike up, starting any engine up, when you first go to turn that thing on, almost all engines require in the territory of 10 to 20 times as much fuel on startup as they do when they're at normal operating temperature, and that's because of course the fuel doesn't evaporate as easily. So when you have bad gas, it's not just that it's bad, it's not like it's unburnable. After about 20-30 days, most of the front end components, they end up evaporating if it's exposed to atmosphere. Modern EFI cars, because they're closed systems, the EPA mandates that it's a closed system so you don't get those emissions from the fuel. Those systems are closed off. The light end components have nowhere to go. It stays in there as a vapor. Your charcoal canister picks it up, and while you're running it burns it off. But the system's sealed, so you don't have that car could sit for 6 months and it'll still sit fine. It's if it's an EFI engine and it's open to atmosphere that you'll have the same problem that you have with carbureted engines, where you've got a tank that's open to atmosphere, that's vented to atmosphere. So what we're going to do is we're going to get that fuel out. We're going to put fresh fuel in that has those liquid light components in it. That'll make it easier to start this thing once we clean that carb up. So first thing we're going to do is take off the old fuel line. This fuel line also looks pretty janky. It's been in there for what, 18 years now. It's a 2003, so this thing running by an air-cooled engine's probably seen enough heat. I think we can retire it. It's earned it. So we'll get rid of that fuel line. We put the new fuel line in. The other thing we're going to do is put some thermal wrap around it to protect it from this engine heat. And when that thermal wrap goes on, that should let this thing last another 18-20 years without an issue. Drain that fuel and we'll move forward. So for now, that's what we're going to do, is start off by removing this old fuel line and getting this old fuel out of there. Alrighty family, we're going to get to draining this fuel now. And you can see this fuel's coming out. And I can tell you, there's some interesting colors in there, man. This stuff is not coming out like the straw color you expect fuel to come out. This is a janky looking orange. So we're going to finish draining this fuel out. And once this fuel is fully drained out, we'll put some fresh fuel in there, run this new fuel line, and we'll get this thing sorted. Alright, I'm going to show you a quick and dirty way to clean this carb. Obviously you don't have to take the whole carb apart. Whenever you're suspecting that there's old, bad fuel in there, it's a little bit varnished up, what I like to do is just take a can of carb cleaner, and not only do you clean the inside of the mouth just to take any varnish out, but the other thing that makes it really easy is you come in through the very top vent. And basically what you're going to do is spray, and you keep filling this thing up. Like I say, you displace the fuel that's in there by spraying carbon choke cleaner in here, a really good quality system, good quality chemical. You're going to basically fill up that float bowl until it forces it to run out of the runoff. Now when you see that coming out here, you're going to see the bad fuel pouring out of here, and I like to give that a nice little whirl. There's a theory out there that if you end up doing this, that you might get a leak or whatever. If varnish is holding your carb together, that has to come apart. So if you get any leaks whatsoever, you're going to know right away there's a problem there. You're going to have to take it apart, rebuild it. But I normally fill the float bowls up till it's, like I say, till I see clear carb cleaner coming out of this vent hose, the overflow hose. When that's done, let it sit for 10-20 minutes. Give it another shot, cycle it through again, let it sit for another 10 minutes or so. That should get it done well enough that if there isn't a major problem in there, you should have a relatively clean running bike. Obviously then you finish draining that out, you run the fuel through it and get fresh fuel in there. Try to start it, see if it starts up, and if it does start up, you're halfway there. Last thing to do is just check if you've got an air fuel ratio meter, like a wideband. Put that in the pipe and see what your air fuel ratio is. At idle you should be around 13.5, 14 to 1 as it's warming up. Obviously if you have the choke on, it'll be a little bit richer, but turn the choke up, like I say, somewhere in the territory of 14 to 1, normal stuff that you'll see. But that's basically it. If you end up getting a leaner reading like that, if you're in the high 14s, 15, something like that, this is going to have to come apart. You're going to have to clean up the jets and like I say, whatever fuel circuits you've got in there. So let's give this a quick whirl, hit it with some of this stuff and see where we end up. All right, family, moment of truth. Let's see if this thing will start and run. Got a winner. So we got it started and running. We think. So now what we'll have to do, let the fresh fuel blow through, and with this fresh fuel blowing through it, we'll get these spark plugs and wires changed and make this thing run like a top. But at least now we got it running. We can move on to testing this regulator. All right, family, next step we're going to do is we're going to test that stator for shorts to ground by putting our positive lead on each of the terminals and negative lead to ground. And basically what we're doing here is just checking to make sure that we don't have any kind of a resistive signal or continuity here, which would indicate a short to ground. In this case, you see we're showing infinite resistance. So clearly this stator, having infinite resistance of both terminals to ground, this is definitely not shorted to ground. So now we're going to check voltage, and after we check voltage, we're going to check the diodes on the regulator. Alrighty, now when we're checking the resistance across the terminals, you can see, family, on the DMM, we've got 0.2 to 0.3 ohms. So we're pretty much right where the factory wants us to be as far as resistance there. We obviously don't have a short to ground, and clearly, there's no open circuit. We are getting some current through there. So next step, we're going to fire this thing up and we're going to put it in AC voltage mode. We're going to check to see if we've got voltage across these terminals and see what it looks like. Alrighty, now once we've got the bike running, you can see, family, that we got 22 volts AC right around. And what we're going to do is we're now going to hook up our oscilloscope to see what the signal looks like on the scope and see if it's as clean as we hope it is. All right, well, what we've done now, we've removed this from the bike just to make it a little easier to explain to you guys what we're doing here. When you're doing a diode test on a regulator, rectifier, basically what you're trying to do is, you think of diodes as check valves. So what you're going to do is you're going to check to make sure that the forward-reverse bias test that you perform, easiest way I think I like to put it is to tell people that when you're checking for a diode, what you're looking to do is to make sure that current is able to flow in the direction you want it to flow and not able to flow in a direction you don't. So for instance, these are the two wires that run from the stator into the rectifier regulator. Then you've got the battery charging wire here. Now this particular regulator grounds through the body onto the bike, and in some bikes you'll see that this has a separate ground wire. Of course, you can run a ground wire from the mounting boss in. Now what you want to do is you want to test from the stator terminals over to the battery charge lead to make sure that if this voltage is ever higher than this one, you don't get current flow going backwards. You only get it if this flow is properly going to charge the battery. So to do that, we switch our meter over to the diode test mode, and we'll bring that in and give you guys a little bit closer of a look at the actual test we're going to run here so you can see the values we're looking for. Alright, now we've set up our multimeter in the diode mode, and again what we're going to do is check to make sure that these diodes are working properly, that it allows current to flow one way but not the other. So the first thing we're going to do is put our positive lead of our multimeter on one of the stator terminals and the negative lead on the battery charging terminal. You see we get a voltage. So that diode bias test is working out fine. We put it on the second pin, second stator pin, call it pin B, pin 2, whichever. You see there too we get a good reading. Now what we don't want is current to be able to go the opposite way from the battery out to the stator. So to test for that, negative side on the stator, positive to the battery output. And you see there we have an infinite reading, which is good, that's proper. We also have the same on the second pin of the stator, so that's testing properly. Now the third thing that we're going to do is when we tested those, we also want to check the bias to ground. So to do that, if the ground is higher than the AC voltage, we can get current flow one way. On pin A, same applies to pin B. What we don't want is positive current from the stator to be able to flow to ground. And there you see we've got an infinite reading there, we've got an infinite reading here. So that checks out fine. Now the third thing we're going to do is check to make sure that we don't have current able to flow from a ground over to the battery. And when we check it this way, going the reverse direction, battery to ground, it's infinite. But when we measure the opposite way, we see that here we've got a bad reading. This should be an infinite reading in this kind of a static case. So now we know this is a defective unit. Let's go back, take a look at the bike. Alright family, so now that we've found out that our regulator is bad, we've tested it, we've determined that it's not working as it's supposed to. We put a new regulator on the bike, but before we get it running, before we hook everything up, this new regulator obviously comes with a proper length of wire that allows you to run back the battery. Notice that it's black. One tip I'll give you, in my experience I've found, it's obvious that sometimes parts fail for whatever reason, age, manufacturing defect, whatever. The thing is that oftentimes a part fails for a reason, and that's the thing. Before you just put a new part on and say, oh, job well done, always test, look around and try to determine why did that part fail. Now the regulator, this bike had a problem where it was charging, suddenly stopped charging. The owner of this bike took it to a friend of his, the guy put a new regulator on, and that didn't solve the problem. Now the thing is, what we found out is, of course, again, try to determine why did a part fail, why did this brand new regulator fail. When we went through the wiring loom to put this new regulator on, of course, before we put everything together, we found out that whoever put this other regulator on, the one that came before this one, they hooked up this charging lead to the battery negative terminal. Of course, you're not going to charge a battery on the negative terminal. That's what popped the regulator. Now the previous regulator might have gone from old age, heat, whatever. I mean, they do fail. The other reason is it could have obviously had a chafed wire rubbing up against the frame. You might have had an intermittent short, stuff like that. So of course these new regulators come with a length of wire. Again, it's black. You got to make sure that you don't hook it up to negative. What we're going to do to make this kind of foolproof for the next guy is to put red heat shrink tubing. When we put the fitting on this wire, we're going to make sure that we run it properly. Again, we're going to put a heat resistant sleeve over it to protect it. Make sure that we affix it properly to the frame. Then before we put the connector on, we're going to put this red heat shrink on so that whoever puts this on next will know, red, this got to go to battery positive. Try to prevent that mistake next time around. So we'll get that taken care of, and we'll fire it back up, make sure it's charging properly, and verify that the job is well done. Always inspect what you expect, family. Always inspect what you expect. Alright, Speed Shop TV family. Like I say, we got this thing finally put back together. Put the regulator on. We ran the new wire. Put, of course, our red shrink tubing over it, the heat shrink tubing, so that we make sure that we clearly have that, you know, for all intents and purposes labeled, for lack of a better word, as a positive wire, so that hopefully that mistake doesn't get made in the future by any techs that may work on this. So just a quick recap. Like I say, we had to get this thing running. Fresh fuel, always put fresh fuel in, just so that you know when you're working on something that the fuel isn't questionable. Gave the carb a quick clean out and got it running to the point where at least we could check then the charging system operation. With that stator, check for shorts to ground, check the resistance across the terminals. If that checks out okay, then end up checking AC voltage. If you've got access to an oscilloscope, by all means use one. These days, if you're doing diagnostics for a living, kind of doesn't make sense to not have an oscilloscope. My first one cost several $1,000s, but these days you could buy a really good one for $200 to $400, depending on the quality you're looking at. The one that you've seen me use, that scope is under $500, so I mean, it's really handy. It's a good quality unit, and at any rate, like I say, yeah, use that. When we found out that the regulator was defective, automatically, like I say, always inspect what you expect, not just looking for the performance of the unit. You want to see why it went defective, why it broke. So in this case, we found out the wire wasn't, you know, obviously hooked up to the right terminal. Always figure out why if you can. And this way, when you put a part on, you're not just going to pop parts and use them like fuses. So that's got back together. We're running now 14.08 to 14.1 volts at high idle, which is great. And the other thing that we did before we hooked it up is, of course, just did a quick current draw test to see with key off, engine off, bike completely off, like you're going to walk away from it for several days, to see what kind of current flow there is in there. We had 0.7 milliamps of current flow, which is fantastic. You know, usually you end up getting, with most computerized vehicles these days, you'll end up having current flow where the manufacturer will state that you could have up to 150 milliamps of current draw with key off, engine off. And that's, you know, that's a little bit of current. You let that car sit for a couple weeks without a battery tender on it, it'll go dead. You know, the battery, you'll get down low enough that it may not start. This obviously being a carbureted bike, minimal electronics on it, we expect a very low value. We had a low value, so yep, we've buttoned it all up. Now all we got to do is, you know, finish changing plugs and wires on it. We'll probably take this carb apart and clean it just for grins and giggles, because it's running a little leaner than we'd like to see, and of course give it a nice wash and should be tip top. So if you enjoyed this, like I say, I appreciate you watching. As always, I'm Dan Maslic. If you want to check us out on, you know, don't forget to subscribe to us on YouTube. And if you want to check us out, we're also on TikTok now. We just started up on TikTok, and that's at Speed Shop TV. We're on Facebook, Speed Shop TV, and on Instagram, Dan M Speed Shop TV. Thanks again for watching. Talk to you soon.